Hello, wonderful people of the World Wide Web. I'm Sean McBride, a student at George Washington University, and I'd like to take a little bit of time to go over a project I completed this past semester. It's something I'm pretty interested in because it combines my interest in two really disparate technologies: social linked data and the Rust programming language. I suspect that many of you may be unfamiliar with both of these topics, so I'm going to take just a little bit of time to kind of explain the theory and backstory of why I'm interested in these things, and then show you my project I've been working on, which I think has a practical application for some folks out there. So, my project is called Hatchling, and in terms of an elevator pitch, you can basically think of this as a tool that allows you to convert the data that you extract from Facebook using their data extraction tool that they provide and refactor that data from the Facebook schema into a web standards based social media profile, which you can self-host or perhaps in the future interoperate with other social networks. So a lot there. We'll get into it a little bit later. So the logo of the Rust programming language is the crustacean. And a lot of people that write Rust are known as Rustaceans. And recently this semester we were going through some concurrency issues. One of them is the dining philosopher problem. And I don't know, I just found this picture really, really kind of funny and kind of weird. Like who would even set up this GIF, right? Or like if you I don't know, walked away for a second and you came back and a crab was eating your food like this, how would you react? I'd probably flip out. I don't know. Anyway, hey, crabs, great. So crustaceans, rustaceans, Rust. So Rust is a systems programming language that takes a lot of inspiration from some higher level languages. So compared to other systems programming languages such as C, which has a very imperative programming style and opinion, or C++, which is multi-paradigm but pretty darn complex, Rust has a lot more kind of modern conventions. And so in a certain way, if you are a application developer and you've worked with higher level languages such as Java or even Python or JavaScript, Rust might be a language you might be able to learn and pick up. And that's pretty interesting just by virtue of being able to expand the aperture of people that can become interested in systems programming and work at that kind of lower level domain, which is something I think all software engineers should try at least once. So as a systems programming language, Rust targets many things, and that includes embedded development. And working in embedded development in resource-constrained IoT-style devices such as microcontrollers, Raspberry Pis, things like that, requires you to really sacrifice a lot of the runtime, because you might be running on a device that has very, very little memory, and it may not be able to support things like garbage collection, or it may not be able to support things like garbage collection efficiently, right? So for those sorts of applications, usually people write in C, like for kind of an Arduino type of thing. And Rust can work in that sort of environment because it doesn't necessarily require a runtime and it doesn't provide garbage collection. It really only needs a stack, which is pretty great. When you give up on having a runtime, you have to make some sacrifices. And one of those sacrifices that Rust chose to make is the sacrifice of full support for what you can think of as object-oriented programming. So Rust allows kind of a a lower level sort of object orientation, which basically includes structs and then implementing methods on those structs. But you can't necessarily create a class and then extend that class into a subclass, or have an animal abstract class and then a dog class and a cat class and a bird class, and then polymorphically go through an array of animals and have them speak in their species appropriate way. You can't really do, well, actually you can do that in Rust, but you have to use something different, trait bound polymorphism. And so the pattern is different, requires interfaces rather than kind of base classes and things like that you can instantiate. So sacrifices had to be made. I personally think this was a acceptable sacrifice to give up on the world of object-oriented Gang of Four design patterns to be able to target this lower level compilation type stuff. That's okay in my book. One other very interesting Rust programming language opinion is the idea of ownership, which is an idea that's been kicking around in C++ for quite some time, called RAII. You can Google that if you want to learn more. But the core idea is that unlike in C, where you can actually just issue mallocs and get back a pointer to an arbitrary bit of memory that was dynamically allocated, which then the programmer is responsible for manually freeing. The default in Rust is not a memory leak, which would happen if you malloc a value on the heap and then forget to free it. The default is automatic cleanup sooner than you would expect. And so that there are some guarantees there that you're going to be cleaned up. It may happen sooner than you want, right? And so that's how you have to kind of learn the Rust programming paradigm of ownership, which includes basically moving ownership between different values on the stack. Because in Rust, everything on the stack is owned by, everything on the heap is owned by a value on the stack. And so when the stack goes through its normal kind of allocation and popping of frames and does the normal cleanup of stack variables, if a stack frame is popped off, then any sort of owning values that own something on the heap then automatically trigger the free action. So it's up to you, programmer, in using Rust to move ownership around on the stack as you write your programming logic. And that allows the compiler to then make a variety of different programming guarantees, which is really great and powerful stuff. So Rust provides some really cool killer features. It kind of feels like a scripting language in certain ways, which I like because I like certain aspects of functional programming. And those tools are provided in a way that is performant and is basically equivalent to C or C++. You get modern package management. So if you are familiar with Rupee Gems or pip or npm or any of those sorts of things, Rust has something called crates.io, which is very similar and has quite a few third-party modules on there, which is just a world of difference from C or C++, where you really have to kind of use operating system level things for dependency management and library management like that. The compiler prevents all sorts of memory errors and provides different seatbelts. Mostly that's based around the ownership model that I discussed earlier. And because of that, you have all sorts of better dev tooling. The compiler is not just a tool for building your code, building binaries like other languages. In Rust, the mentality around the compiler is it also, in a certain way, provides useful programmer feedback and debugging messages. And you can kind of think of it like you're basically pair programming with the Rust compiler team to a certain degree. When there's an error that they can detect, they will present a very user-friendly error message, often linking to like tutorials and things like that to help you understand the idiomatic Rust solution for whatever problem you have. So it's a very positive and uplifting educational experience to learn systems programming via the Rust compiler. Finally, the best feature, in my opinion, of Rust is they have the best WebAssembly support in the biz. So WebAssembly is basically a architecture neutral compilation target. You can kind of think of it like sort of like the JVM or the .NET CLR. You take your source language, you compile to this intermediate thing, sort of like a bytecode, and then as long as there is a interpreter for a processor architecture that is able to ingest that bytecode, you're then able to basically compile, write once, run anywhere, right? Which is pretty cool. And unlike the JVM or CLR, this is much lower level, more like an LLVM type thing. And so that means the overhead's a lot less, more like 20% compared to C or C++. And the performance is consistent too. So let's talk about Rust by the numbers a little bit. Rust is generally a very loved programming language, which is kind of a mixed bag, right? Because programming languages that are very successful are less loved because they're so adopted that people have to use them whether they want to or not. Like enterprise Java, right? That's ubiquitous. That's kind of like the COBOL of 2019 is enterprise Java. And boy, look at the job numbers there. 204,717 open jobs for Java developers. That's a crap ton, right? But it's less loved because people have to use it. So I don't know. That means that Rust being highly loved also reflects the fact that there aren't that many jobs available for it, right? There are quite a few conferences, quite a few packages, courses, GitHub projects, but those are mostly all passion projects. People are like flushing out the initial package ecosystem for Rust and trying to use that to build up their developer celebrity and credibility and position themselves to take advantage of Rust becoming more popular and mainstream in the future. So that's kind of the state of things. If you are trying to get a Rust job, like realistically or otherwise just write Rust at work, you really have two options. The first is like get enough authority or autonomy in your company to be able to just adopt Rust, perhaps inside of an existing C or C++ code base, or as a solution for WebAssembly and maybe a front-end web app. That's probably some of the most common use cases. The second is for the handful of Rust jobs out there. If you want to have a shot at getting one of those, you probably need to be active at Rust conferences, go into local meetup groups, things like that. And because that's probably where people are getting hired, right? I mean, like, why would you ever post a job listing for a Rust job if there's a bunch of enthusiastic people at a local meetup group that you potentially know that you can hire, right? So let's take a look at some performance numbers here. And the key takeaway here is that when you look at Rust performance for a variety of different sorts of algorithms, you can see it's roughly the same as C or C++. Sometimes better, sometimes worse, depending on how optimized some of the implementations are, but definitely faster than Java or JavaScript. In fact, I bet like most of these Java application or Java implementations for these benchmarks are pretty darn optimized. So I would expect Java and JavaScript to normally be worse in practice, right? Because you can optimize quite a bit for benchmarks with these higher level languages, but that doesn't represent the quality of your average Java or JavaScript application out there. So lots of gains to be had by doing work in Rust, and if Rust provides some of the higher level facilities that are familiar with Java or JavaScript, but has some of the performance characteristics of a C or C++, it's a very compelling sort of language. I used to work in enterprise IT, in particular in the government, and in that world, Gartner consultants have a heck of a lot of sway with kind of IT management decisions. A lot of the Gartner stuff seems a little bit silly to me as a technical person, but I do like this idea of this IT clock, right? So you can kind of imagine this as like a clock on the wall. We have 12, 3, 6, 9, 12, and one cycle around the clock here, so 12 hours, is basically like the entire lifespan of a technology. And when you break this up into quadrants, you can kind of think of this as like, this is the early adopter enthusiast crowd. This is the startup crowd. This is kind of the mainstream Fortune 1000 crowd. This is like legacy technology land up here, right? So you have these different quadrants which represent the state of programming languages, or databases or app servers or operating systems or whatever the heck you want to talk about. Gartner is like a clock for all those things. Here's the language one, and they didn't actually have Rust on theirs, and so I tried to basically decide where to add the Rust dot, and I put it right here. And what that means is Rust is still very much in the early adopter phase. It's starting to get some work at startups and some of the early adopter type companies, but it's kind of slow and like slowly kind of trickling out there. Some big tech companies are also interested in Rust. Fastly, Microsoft in particular, like Microsoft is starting to hire for Windows development and make it so Rust is a first-class programming language for any sort of Windows component, which is a big deal. Let's see, who else? Facebook chose Rust for their controversial Libra cryptocurrency project. And they said they chose it because it has a lot of security guarantees, which is important for financial stuff, right? So anywhere that you think security is really important, and memory leaks and all those kinds of traditional security exploits in C++ are a problem, like that's kind of where you're going to see the early adoption for Rust. And it's definitely a bit behind Go, which Go is at this point, I would probably say not here, goes in here somewhere, because it's really used heavily with microservices centric organizations based around Kubernetes and the CNCF. Like those sorts of places, including the startup I worked at before, are very much writing Go in production and using it as an alternative to basically enterprise Java. So Rust isn't there yet. It's a little bit behind, but it's moving quick. So I would say within the next 1 to 2 years, we're going to start seeing a lot more mainstream Rust adoption. In particular, once like Microsoft starts pushing out their first-class support and talking to the Fortune 1000 about Rust and the advantages it offers, I expect things are going to pick up quite a bit. Don't know how that's going to compare to Go. I personally am, I guess, a Rust maximalist, and I think Rust has the potential to take on Go. Like I'm going to go ahead and say I think that might happen. Knock on wood. We'll see. So, but if you're like thinking about getting a job, you realize this, like it's going to be hard to just get a Rust job compared to Java or C or C++, right? So this you can't necessarily put all your eggs in the Rust basket. I have a couple of REPLs I put together to show some of the advantages of Rust over C. So I'll paste these links in the YouTube video description. If you want, you can click through and basically interact with the same code written in C and Rust, and to see some of the potential security vulnerabilities in C and how Rust protects against that. So now I'd like to move on to the project I actually worked on, Hatchling. As I mentioned before, this is a tool to help you break out of the Facebook egg and swim free in the ocean of social link data. So you're like this little sea turtle guy, right? You're looking out to the sea, trying to get out of the egg. Probably there's some predators out there on the beach, so hopefully you can get out to the ocean quickly enough. And the faster that you can go from kind of the centralized social network to social link data, so the better your onboarding process, the better chance you have at having the social link data thing be viable for you, and then build up a little bit of an ecosystem around that. So we're trying to protect the little sea turtles, get you out to the ocean, make this thing work. That's where Hatchling is operating. So if you're not familiar with social link data, I would suggest that you read up on some of the things that Sir Tim Berners-Lee spoke out on a little bit more than a year ago. Tim Berners-Lee is the original creator of the World Wide Web. He is a Brit, and so he was knighted, so that's why he's now Sir Tim. Like a year ago, he started basically having a little bit of a press circuit where he's going around talking about the World Wide Web and how he thinks his creation has kind of taken a crazy turn. So a lot of people were comparing that to some of the physicists that worked on nuclear weapons and how they later came to sort of regret their creation. That was sort of some of the tone that Sir Tim had. So he said that the web has evolved into an engine of inequity and division, swayed by powerful forces who use it for their own agendas. Today, I believe we've reached a critical tipping point, right? I don't know if I necessarily agree with Sir Tim on all his politics about this. I actually personally kind of like Facebook. Both of my septuagenarian grandmothers are on there, and as someone that's done web development, I realized like creating a compelling product that a septuagenarian that may not have a lot of experience with computers can use to interact with grandkids, that's a tough problem, right? And Facebook has thrown a lot of developer time at that, and I think they've cracked the problem pretty good. And they've also given back to open source tremendously, right? With all sorts of things, including like the React framework. So I don't necessarily have a huge problem with Facebook. Other folks might. I think Sir Tim does in particular. But I am a fan of user choice, right? And so a lot of the things that the social link data folks are working on are very architecturally interesting to me. And I think that adoption of those sorts of technologies, even by Facebook, would be a pro user move. And I would very much like to see that in the future. So what are kind of Sir Tim and some of the other folks concerned about? They're concerned about a variety of different issues, some of which Solid would fix, some of which it wouldn't. The first is kind of tech addiction, right? Internet addiction. I don't see Solid as solving that per se. The second is Cambridge Analytica and the scraping of user data. I think Facebook has some trust and credibility issues around some of this, most of which they've addressed at this point, I think, because they've staffed up a lot of security and privacy folks. They've added the data export tool, things like that. They've eliminated a lot of the APIs, which I, as a developer, would probably like, but were abused by some of these bad actors like Cambridge Analytica. So would a decentralized social network necessarily protect against, Cambridge Analytica? It's hard to say. I mean, if every user is self-hosting their own data, how great are people at protecting their own passwords and things, right? Like, I kind of think to some degree some of these centralized social networks probably protect my septuagenarian grandmother's data than she could herself if she were administering her own server and like hosting her own data and stuff. So this one, though, like this kind of siloed problem of you have different data in different networks, this is kind of an old image from The Economist. Yeah, so we got like Flickr and Orkut and some random MySpace. Hey, MySpace. But I mean, it's still a problem, right? So if you have a LinkedIn profile and you have a MySpace profile and a Facebook profile and an Instagram and a Snapchat and all that, right? You have profiles on each, you have notification feeds on each. They're each trying to compete for your attention, and they're very like they're kind of islands on the World Wide Web with their own different user experiences. So this very much is a problem that I think the social link data solves. And then finally, fake news. Um, Again, like in fact, this might actually be exacerbated by a decentralized social network because it potentially means that users, they have their own kind of news feeds that they're aggregating. And I would think that that would be a little bit easier to game as a bad actor, if they're because you really don't have like a Facebook security or privacy team checking your news feed at that point, right? So I don't know. So I'm mostly going to focus on this problem here, this interoperability thing. I definitely think some of these others are issues. I mean, they're kind of social problems, though, right? Or regulatory problems. I don't necessarily think any sort of technical solution is going to be a big fix for that. In fact, decentralization is going to make solutions to some of these problems harder because there are going to be more actors that are going to have to collaborate and set standards around to make that possible, which probably is a better thing for society. But you know, I don't know. So anyway, let's talk about the technology now that I've talked about some of the social problems. So the core idea of solid social link data is that rather than having your profile data hosted by Facebook or LinkedIn or Twitter, you host that data yourself using kind of web standard schemas that mean that there's interoperability between all those different providers. So you can kind of think of this solid pod as similar to like a Docker instance, right? So you've got, or Docker, what am I saying? Dropbox, yeah. So you got Dropbox, or you got Google Drive, or you got some sort of storage hosting provider, and you have like normal files and things in there, but you also have special files that are containing structured data with those W3C standard type schemas, and that allows this to be kind of like a decentralized database for social networks. Your identity on the internet is represented by your solid pod. And so for me, like my human name is Sean McBride, but my globally unique internet World Wide Web name is then Bushido Codes, basically. And we'll talk a little bit more about how that ends up working in a bit. So we have our data host, we self-host our data in our own solid pods. Presumably we can either self-host, because this is all open source, or probably a better solution would be we have a kind of infrastructure provider that provides a solid pod on our behalf and are aligned to our data privacy interests as individual users. And then the different social networks basically request our profile or update our profile, add notifications and store files. And you can kind of think of this as sort of the permissions model provided by like an Android app or an iPhone app, where when you install an application, it asks for certain permissions, right? Like, do you want to give this app the ability to read your profile information, or update your profile, or publish notifications to your feed, things like that. And that's basically the model you would then have on the web, because we would have this standardized solid pod. And we can in fact then have multiple social networks accessing that same data based on the permission model. And so, for example, let's say you get married and you want to change your name. At this point, you'd only have to update your name once, and that identity would then cascade out to all your social networks. You wouldn't have to do that on Instagram and Snapchat and Facebook and all that, right? If you update a piece of your profile, you just do that once, and it gets all the changes basically get inherited out from all the different social networks. Similarly, if you want to update or you want to post a picture on Instagram or Snapchat or something like that, it becomes then easier to do that across social networks because the photo is stored in your solid pod, and you grant basically access permissions to the different feeds provided by the different social networks. And that basically means you can have just more of a consistent experience across the different applications. So I use an app called Buffer to basically post to Twitter and LinkedIn and other things like that, and schedule my posts and things like that. One of the features that Buffer app provides is just knowing all the different proprietary state formats for those different social networks and knowing their APIs and things, right? In this kind of model, you wouldn't necessarily need a buffer per se. You could have like post a picture to your solid pod and have that be shared out with your different networks pretty easily, right? And then the notifications, like if your friends are posting pictures or like or comment on your picture, they can then be fed back into a unified like notification stream. So you could have all sorts of things in there, right? Your septuagenarian grandmother comments something on your Facebook, your young hip cool friend, like, I don't know, comments on your Snapchat, and your LinkedIn recruiters offer you a job you're not interested in on LinkedIn. And of course, like, once you have a centralized feed, you can then have rules around that, right? So you could have sort of new features that you couldn't have before because of the disparate user experiences of the social networks that then become feasible. Like maybe Apple embraces solid pods, and then they provide kind of a out of box, better walled garden, user friendly approach to handling notifications across all your different networks, right? And then integrating that maybe into your like hours when you want to go to sleep or when you want to get notifications. Really cool possibilities here. So you might be thinking like, okay, stateful programming, that's something I'm sort of familiar with. And one of the problems with stateful programming is you have to define schemas, right? And when you define schemas, they're usually special snowflakes because nobody can really agree on like how to define a person or how to define a this or that in the common way. Everyone names it differently. Sometimes it's even stupid stuff like camel case versus snake case and all that, right? So how do you kind of standardize on that? Well, the solution for this is actually pretty old, and it's something that a very young Tim Berners-Lee started working on even before Facebook became mainstream, and that's this idea of the semantic web. So this is kind of like a retro idea that Sir Tim is trying to bring back from the dead a little bit. And so let's talk about kind of how it works. Well, there's really 4 commandments for linked data that I think are really important here. The first is that the World Wide Web is a global namespace. You might not really think of it, but every time you type something into an address bar, like you're just typing in a unique name representing something on the web, right? And that's something we use today to reference HTML or CSS or JavaScript files or videos or all sorts of different things. But we could extend that idea of this global World Wide Web namespace to structured data also. And that's the promise of the semantic web. So our schemas for how we represent people or our instances of a person are then all represented by a URL. And we can use HTTP verbs to interact with that structured data and reply with data encoded using our semantic web standards. And that data forms basically a knowledge graph, because it's not just like a deeply nested blob of JSON like what Facebook would provide. It is a a block of semantic web content encoded as linked data triples, and those linked data triples link to other things, and so you basically form a knowledge graph. So to give kind of a more concrete example, imagine we have two people. Walt Milo, the instructor for the class I wrote this project for, is a person, and he's represented by a website. I'm a person, I'm represented by a different website. And then there's a abstract thing called hang gliding, right? That's not a person, that's just an abstract concept, right? But it's also represented by a URL. And so we can link all those URLs together using linked data triples. This is written in that turtle format that I referenced earlier. And you can kind of think of this as triples as a sentence with three parts, right? Subject, verb, object. So here's Walt's turtle file. Walt is a person. Walt has the name and then the string Walt Milo. Walt is interested in this thing, this URL. We don't quite know what that is, but our browser can then do an HTTP GET request to that URL to find out more about it. Walt is the teacher of this URL, right? And you got to do an HTTP GET to that URL, and then you get my information. And so when you crawl this, you end up finding out like hang gliding is a sport. Hang gliding was created by Leo da Vinci. And like you can keep following these links out because it's a graph. Or here's me, I'm a person, I've got the name Sean McBride. And so when you draw this out as a graph, here's what it kind of looks like. And all of these edges are typed by schemas. And that makes it so the knowledge graph is something that a machine can understand, right? Because these are type schemas. So here's an example of a turtle file that is generated when you create a solid pod. And you can see some different things. Some of these are familiar, like name. And some of them are a little unfamiliar, like preferences and some other things. Notice these are all basically turtle files, right? So it's a very extensible idea. And like I mentioned, the schemas are kind of the secret sauce of the semantic web. And one of the things I think is kind of funny is some of these schemas are pretty old, right? So this is the friend of the friend schema, and it defines basically the attributes that define a person here. And if you look on here, you can see like AIM, right? So I basically met my wife on AIM like a million years ago. And it's still part of this friend of a friend schema, even though the AIM service is dead. So we've got, ICQ, Yahoo, MSN. Some of this stuff is kind of deprecated and old. A lot of it's still useful. And so I've used it for Hatchling. You might be thinking like, okay, if this friend of a friend thing and semantic web thing is so interesting and it's so old, why have I not really interacted with it? I mean, that's kind of an interesting question, right? Like there's an alternate history where we as society decided to go down this decentralized web standards based social network approach rather than Facebook. And we'd be in a very different world today. So we haven't done that. And for the most part, we think of social networks as platforms that we kind of exist on. But even in the case where we're in this platform-based universe, you've still used linked data. You just haven't necessarily understood that. So if you use Google, right, here's kind of the normal back rub search algorithm results based on the hyperlinks and web pages, and then over here on the right, this is the Google Knowledge Graph, and the Google Knowledge Graph is built at the end of the day on linked data principles. So the Google web crawler will basically inspect web pages and inspect like turtle files and things like that, and it is able to then parse out this structured data. And so that's how it's able to know all this information about Sir Tim Berners-Lee, including this typed information here, like when he was born, where he was born, where he went to school, stuff like that. Like normally that would be text, right? And even though natural language processing is more advanced, like computers cannot just naturally understand text. They need structured data. So this structured data is basically powered by the semantic web. So if we come back to the project here, we can see the Hatchling project has the purpose of taking data from Facebook provided by the data export tool, which gives us JSON files. We then use the Hatchling project to be able to transform that data into turtle files, and then we can basically upload that to our solid pod. So this is kind of the missing piece here, the bridge that takes you from Facebook into solid. So some of the tools I used are pretty much all the standard Rust stuff: Rust compiler, VS Code Rust extensions. I use some pretty common Rust crates, including clap, which is a really good command line parser, Surd, which I call a JSON parser here, but it does a lot more than that. It does a lot of other formats, I think YAML and all sorts of other ones. And then pretty interesting semantic web Rust crate called RDF, which in fact provides an in-memory graph database and then the ability to serialize data out to formats, including Turtle, which was super useful for us, or useful for Hatchling in this project. Finally, I had to pick a couple of schemas, which I thought mapped pretty cleanly to the Facebook profile. And I used friend of a friend, which I mentioned earlier. I used schema.org, which is the schema that Google search knowledge graph thing uses. And I used vcard, which is kind of the original W3C schema. So here's the architecture for the project. Like many Rust command line applications, I've broken things down into a back end and a front end. The front end provides the command line interface functionality, such as taking in files and then writing files back out to the operating system. The back end just takes an arbitrary string encoded as JSON, and it returns an arbitrary string encoded as semantic web triples encoded as turtle, right? And so that's super useful, because then you could take the backend library and use it in other contexts, maybe in like WebAssembly or desktop applications or any number of other things. It doesn't just have to be command line. We're not tied to that. I had a couple other architectural goals I wanted to achieve. One is that, Facebook is a pretty popular social network, and they have a really good data export tool, which is great. But there are other social networks that we might want to export our data from to be able to then import into our solid pod. And that could be LinkedIn, that could be Twitter, any number of things. If we wanted to do that, we would have to create annotated schemas for the proprietary schema that each of those social networks use and that they expose via their data export tool. So Facebook is supported now. Other social networks could be provided in the future. And this is this is encapsulated in a way that this could be added fairly easily. Another architectural goal is that I wanted to really insulate working with graph data structures, because I know it's a idea that is pretty foreign to most application developers. So to be able to do that, I wrapped it in a facade. I wrapped the RDF library in a facade and provided essentially a ORM type functionality where you have essentially a profile and you set attributes on that profile, and behind the scenes the RDF library and my logic generates the semantic web triples for you, but you don't have to worry about it. So quite a bit easier. The architectural outcomes here are basically everything I mentioned already. Yeah, so let's just go forward. So now I'm going to go ahead and give a quick demo here. If I open up my editor, here is the Hatchling project. You can see that I've currently got the resulting turtle file generated here from just a previous test run. It's a stack of a lot of data here, right? So that's the output. The input is a variety of JSON files provided by the Facebook Data Export API. That includes this like profile information here. I've redacted some information because I like my privacy. So yeah, and I also have a second file here called friends.json. This is something that I've created a special script to pull because one of the problems with the Facebook data extraction tool is they provide only like the first and last name of your friends. And it turns out just human names aren't all that great because they're not unique, right? So my name is Sean McBride. I think there's probably like over 100,000 Sean McBrides in the world because it's a pretty common Irish and Irish American name. So if you want to be able to identify which of the 100,000 Sean McBrides you're talking about, you need something more unique, like a URL. And Facebook's URL for a profile works great for that purpose. But to be able to get that, you have to basically run the special script I provided in the repo. So if you want to go through that extra step to be able to generate your friendship network, your social network in your solid pod, you have to basically go through a couple of extra steps, which I identify and walk you through. Not too bad, but it's optional. So you can choose to do that or choose not to do that. So I'm going to go ahead and delete this output turtle file and regenerate it. So I have several different ways to be able to run Hatchling since it's multi-platform. Since I have basically my Yori Windows cmd.exe style shell up right now, we'll run that first. So basically we're running hatchling.exe. We're passing in the 2 JSON files I mentioned earlier, and we're outputting the turtle file that we want to generate. Right? So we run that, and we regenerate our turtle file. Right? It's the same information. Some of the ordering of some of these lines changes a little bit, but otherwise it's all the same content and parses the same way. All right. So that's Windows support. Let's go ahead and remove our file again and regenerate it. Now let's use native Linux support. So basically we run it the same way, but we use the // format for invoking a Unix binary. And we output our turtle file again, same content. Let's go ahead and delete it again. And the last thing I want to show is WebAssembly support. Like I mentioned earlier, WebAssembly it's essentially kind of like the JVM or the .NET CLR. It is a processor architecture agnostic compilation target, which you can compile to using the Rust compiler. And then that ensures that whatever host environment you're running it on, as long as it has a WASM interpreter, basically you're able to then run that .wasm file. So think write once, run anywhere kind of thing, right? So I have a WASM interpreter called WASMTime provided by Mozilla, which I'm going to use to execute my hatchling.wasm file. And WASM has a special security model, so I also have to provide this //dir to say that the WebAssembly runtime has permission to open up the host directory, because this is a secure sandbox, basically. So we run that, and it runs basically the same speed as a native module, maybe like 20% slower kind of thing. And we get the same data out here. So that all works pretty good, right? And here in the second tab, I'm running a web server. And the web server is serving out the files. Let me just go ahead and stop that and restart it to make sure it's serving the latest and freshest content. So now I can access this turtle file over the net to demonstrate that this is not just, some arbitrary text, but this is something a semantic web aware application can actually use. I want to use a profile viewer application that I wrote about a year ago. So here we can see we can open up the file. So this is accessible via HTTP. And here is the profile viewer that I wrote about a year ago for a conference. I'm currently opening the profile of Ruben. He's a a professor of the semantic web, and so his profile is very much on point. And so this is just to show that we're parsing his stuff, which was not generated by Hatchling. It's generated using the standard schemas, right? And so we can see his friends. We can see Sir Tim. He's got a profile picture. We can like click on these and open up their profiles. So because we're using the schemas, like we're able to just kind of parse this turtle data, right? And so that means if we open up this URL, we should be able to open up the profile I just generated using Hatchling. Let's see if that works. And it looks pretty good. So I don't have the ability to support photos at this point, but our other data went through. I'm not supporting the age thing either because that seems a little silly compared to like birth date, because ages change all the time and they're not really static, right? We get older every year. So I am supporting other things here. We can click through since I added the friends data and we load all of our friends information. We don't know a lot about our friends. We really only know the URL of their Facebook profile and their name. And so if we click on their information here, this is all blank, right? But we see the name and we see the link. So if we click through on Adam's stuff, we can then see his information here. Big Star Trek nerd, obviously. Yeah, so all the Hatchling stuff is working pretty great. If you're interested and you want to give this a shot, here's the repo, Bushido code/Hatchling. Give it a shot with your Facebook exported data. And if you have any problems, feel free to open up any issues and I will get back to you and try to fix whatever's broken. Otherwise, I hope you have a wonderful holiday season. And if you have any questions, feel free to let me know in the YouTube comments below. Thank you.